everybody, and welcome to exercise 1 on page 46 of the workbook here. Okay, so this exercise is asking us to take the derivative of a couple of functions, and it's going to be up to us to decide which derivative rules apply in each situation. Let's do these one at a time, starting with part A here. So there our function looks like x squared minus the square root of x quantity, all of that times cotangent of x. Okay, so out of the derivative rules we've talked about, which one jumps out at you there? Okay, I'm seeing a product of x squared minus the square root of x times cotangent of x. So seems like a natural choice to use the product rule in this case. So if we do that, we're going to get the first function times the derivative of the second plus the second function times the derivative of the first. Okay, and to finish the problem, we've got a couple of derivatives that we need to take. The derivative of cotangent and the derivative of x squared minus the square root of x. Okay, so let's start with the first piece here. The derivative of cotangent of x, there would be helpful maybe to scroll back up to our table. We wrote down a formula for cotangent of x a couple of pages ago that looked like this. It's negative cosecant squared of x. Okay, so we'll go ahead and fill that in. Okay, and then we've got cotangent of x, and now we need to take the derivative of x squared minus the square root of x. Now, just to help us, I'm going to remind you that the square root of x can be rewritten as x to the 1/2. Okay, making that observation allows us to notice that that's a power rule derivative. Okay, so if we start with the x squared, that's going to have a derivative of 2x, and then the derivative of x to the 1/2 by the power rule, bring the 1/2 down, and then subtract 1 from the exponent, we're going to get 1/2 x to the negative 1/2. Okay, and we have taken all of our derivatives, and so that would qualify as a final answer right there. Okay, let's move on to part B here then. Okay, so if we want to take the derivative of 2x plus 1 over 3x minus 4, what kind of a function do you see there? Okay, I'm seeing a quotient this time, a ratio of 2x plus 1 over 3x minus 4. Okay, so we'll use the quotient rule on that. So we're going to have low d high minus high d low all over low squared. Okay, and to finish that, we've got a couple of derivatives that we need to take. Okay, so starting with 2x plus 1, and then derivative of 3x minus 4. If we can take those two derivatives, we are done with this problem. Okay, so what would the derivative of 2x plus 1 be? Well, x is x to the first, remember, so the 2 is going to kind of come along for the ride, and the derivative of x to the first is 1x to the 0, which is just 1. So actually we're just going to get 2 times 1, and that plus 1 at the end is going to disappear. Okay, and then similarly over here, when we take the derivative of 3x minus 4, the derivative of 3x is just going to be 3 times 1, and that minus 4 is going to disappear. Okay, and then finally, we could maybe simplify this one more time. 2 times 1 is just 2, of course, and then 3 times 1 is 3. Okay, now I'm going to stop here. Make the remark that if you wanted to, you could simplify this further. You could multiply the 2 out and the 3 out, and this does simplify a little bit. I'll leave that up to you, okay, on a problem like this. This answer is perfectly acceptable to me, but you were looking at maybe answers in the back of a textbook or something. It would probably simplify this a little bit.